The Pythagorean Theorem. First thing that we need to know is the Pythagorean Theorem has to do with right triangles. And in a right triangle, there are two sides that are called legs, and they are what are attached to or adjacent to the right angle. And the third leg is called the hypotenuse, and it is on the opposite side of the right angle. We usually label the legs as A and B, and we label the hypotenuse with C. Now, when we're talking about the Pythagorean theorem, we're trying to identify what sides might equal, and in a right triangle, it's very easy because we have the Pythagorean theorem, and the Pythagorean theorem is just A squared plus B squared equals C squared, which is the leg squared plus the leg squared equals the hypotenuse squared. Now, in this example, we're given the leg values of 8 and 15. So if we plug that into the Pythagorean theorem, we would have 8 squared plus 15 squared equals C squared. And we just solve it from there. 8 squared is 64, 15 squared is 225. We add those together, we get 289. The square root of 289 is 17 because we wanted to get C by itself, and we didn't want what C squared was. So the square root of C squared is C, so C equals 17. Now remember, if this was in inches or centimeters, we'd have to label it in whatever the label is that we're given. Another example, if we're told the legs equal 24 inches and 45 inches and are asked what is the hypotenuse, we would simply set this up the same way, because 24 squared plus 45 squared, those would be our legs, equals C squared, which is our hypotenuse. 24 squared is 576. 45 squared is 2,025. We add those together, we get 2,601. Again, we want to find the square root of both sides because we don't want what C squared is, we want what C is. So the square root of C squared is C. The square root of 2,601 is 51. In this example, we're given kind of a situation, and we have to draw our own scenario. So a doorway is 2.7 feet wide and 8.4 feet tall. What is the longest piece of drywall that can fit through the door? Well, in this case, we can fit a piece of drywall in at a diagonal. We don't have to put it in either straight forward at all. We can turn it diagonal. So in this case, we would draw this example just to kind of visualize what's going on. That's not necessary, but you can do that for help. So we take 2.7 squared plus 8.4 squared equals our hypotenuse squared, because that's where we're going to be able to put it at a diagonal to put it in the door, which is C squared. So 7.29 is what 2.7 squared is, and 8.4 squared is 70.56. If we add those together, we get 77.85 equals C squared. And again, we don't want C squared, we want C. So we take the square root. So the square root of 77.85 is approximately 8.8. Now, we would need to label this with feet because the problem that we were given was labeled in feet. If you're asked to identify a right triangle and you're given three sides, so in the first example, 6 centimeters, 8 centimeters, and 10 centimeters, we take the smaller two because the hypotenuse is always the largest side no matter what. So we take the smaller two, and those are our A and B, and the larger one will be our C. So 6 squared plus 8 squared should equal 10 squared if this is a right triangle. 36 plus 64 should equal 100. 36 plus 64 is 100, so since 100 equals 100, yes, this is a right triangle. Now, in the second example, we're given 4 inches, 5 inches, and 6 inches. So we take the smaller two, 4 and 5, those are our legs, and 6 should represent our hypotenuse. So 4 squared plus 5 squared should equal 6 squared if this is a right triangle. 4 squared is 16, 5 squared is 25, and 6 squared is 36. However, 16 plus 25 is 41, and 36 do not equal each other. So 41 and 36 are not the same, so the answer is no, this is not a right triangle. The next example, if we're given the data without a drawing or anything like that, and in this situation we're given B is what we don't know. So we're told A equals 9, B we don't know, and C equals 12. Set it up the same way. 9 squared plus b squared. Now we just put a b there simply because we don't know what it is, equals 12 squared. And we just solve from here. 9 squared is 81. 12 squared is 144. So 81 plus b squared, because remember we don't know b, we know a and c, equals 144. Now we have to get b by itself, and in order to do that we have to subtract the a's. So subtract 81 from both sides, and 144 minus 81 is 63. Now again, we don't want to know what b squared is, we want to know what b is. So what is the square root of 63? So b equals approximately 7.9. Another example of this, let's say we don't know what a is. We're told b equals 16 and c equals 29. Set it up the same way. A goes first, a squared, plus b goes second, so 16 squared equals c squared, so 29 squared. Go ahead and solve out what you can. So we're left with a squared. 16 squared is 256. 29 squared is 841. We have to get a by itself, so in order to do that we have to get rid of that 256 that's on the same side, so we subtract it. 841 minus 256 is 585. We don't want to know what a squared is, we want to know what a is, so we take the square root of both sides. So the square root of 585 is 24.2, so a equals 24.2. Typically we're going to round to the nearest tenth unless we're told otherwise, because square roots, unless it's a perfect square, are going to give us a decimal that goes on and on forever, doesn't have a pattern. That's one of those irrational numbers that we talked about. The last thing that I want to mention is that when you're doing this, make sure that you're paying attention to where the hypotenuse is. Remember, it's the one that's the biggest number. It's the one that's opposite of the right angle. It's going to be on the right-hand side of your equation each time. So if you're given C, but you're not given one of the two, A or B, you know then that you're going to be solving by subtracting before you take the square root.